In this module, I'm going to discuss some methods for data transformation. Let's get started. I'm at this point opening up the slides on data transformation, and I'm also going to simultaneously pull in a starter Tableau workbook that I'll be kind of working through here as I discuss data transformation. Here are the slides I alluded to earlier. These slides discuss the various methods for transforming data using Tableau. So here we're going to look at data transformations, create new variables, aggregations, hierarchy set, and parameter, and lastly, table calcs. Data seldom comes in the format you want it to be in or in a readily usable format. So oftentimes you need to convert it, transform it to make it useful for conducting analysis. We're going to begin here by examining the various ways within the Tableau environment to create a new variable. In general, to create a new variable in Tableau, you will use the calculated field option. Let's begin by examining a few examples of how you can go about it for various goals. These are organized in the workbook called Tableau Starter Workbook Data Transformation. In this workbook, you're going to find a number, you're going to find I've used the sample superstore data set here to construct some simple tables so you can kind of see the effects of data transformation. In the bottom, you'll notice are tabs for the various, are a number of different tabs where I'll be creating I'll be representing data transformations. So on our first tab, we have a simple table including information on 3 measures: discount, profit, and sales. They are aggregated as described here as average, sum, and sum. The numbers under those are your measure values, and we have 4 years of data here. It's a very simple table that we're going to be using to discuss the various data transformations. Let's begin with a very simple one. I'll click on the numeric variables table tab, and you'll see an identical table in front of you now. So I'm going to conduct 2 simple variable transformations. So imagine you wanted to construct another column of data that is like arithmetic transformation of the first one. To illustrate, imagine you want to find out profit after tax. You already have profit here, so you want to find out profit after tax. You apply some formula to profit to figure out that amount. For illustration only, let's assume that there's a flat 10% tax, right? So the tax is 10%, then the amount after tax would be 90% of the original profit. So we're simply going to do 0.9 times profit to create a new variable. We are creating a variable that is a derivative of profit. So I'll navigate over to the left where I find the variable profit under measures. And there I'm going to go and create a calculated field. This will pull up a window for profit. Okay. I'm hoping you can see the window and it doesn't disappear. So there's a window in case you're wondering or can't see us. There's a window that came up now with the calculated field window. And in this window, I'm typing in profit after tax as the variable name. Now, the variable, the level of aggregation of profit is sum in the main sheet. So I'm going to go and call this sum profit so I maintain the same level of aggregation. And to this aggregate data, I'll apply the 0.9 like multiple or multiply by 0.9. And you can, of course, always, put in comments here so you know that what this means, right? So 10% tax rate, I'll say here, right? And so // is a way to enable comments in Tableau's calculated field pane. So having done this, if I hit OK now, you'll see we have created a new variable on the left called profit after tax. The small equal to by the hash mark is a sign that the new variable created is a calculated field. If I drag this over right next to or below some sales under measure values, you'll now be able to view profit after tax in the table. Now, let me repeat the same task for another transformation. Let's say we want to find out the log of sales. So I'll go into sales, again, create calculated field, and then I'm going to say, let's call this log sales, okay? Now let's say we want to do a certain kind of log called a natural log. Tableau comes with a number of built-in functions that can enable you to perform logarithms. Like in a calculator, you've got a button for log. In Excel, you got a log function. Well, Tableau has those too. So when I hit on this, click on this arrow here, it opens up on the right a whole slew of functions. These functions are categorized into number, string, date, and so on and so forth. I'm going to select here number because I think log is a numerical calculation, only applicable to numbers, not dates or strings. Now, from this list, let me make it easier to find L by I'll click on L and it'll take me to the L functions. So they're providing me then a nice doc string, like a description of the documentation of the function. It shows, for instance, here that ln is a function, and you're applying that function inside parentheses to a number. And they also provide a nice example. This is telling me that it's a natural logarithm. So ln is not no ordinary kind of log, it's a natural log. So as before, let me apply this natural log to some sales. You can either type out ln right next to some sales, or if you have already highlighted some sales, and you were back in this menu here on the right side, you could literally double click ln and wrap around some sales as follows. Okay, having done this, I'll hit OK, and now I've got another variable called log sales on the left, excuse me, on the left. As before, I'll place that under measure values, and you'll now have another column called log sales. There you go. We now have two new variables we created, one called profit after tax, one called log sales. We're going to now move on and examine how you can do calculations with words. Here is a table containing the names of our customers and how much money they spent. We have customer name, Sean Miller, and how much money he spent, and so on and so forth. Now, let's say our goal is to find out or extract their first names, because we want to put that in an email. So we want to have that, be able to pull that out and just stick that into a mail merge email type system so people get personalized emails. So we want to extract their first name. If you think about the logic behind this, you can probably reason that first name basically is whatever happens before the first space in the name. So Sean Miller. So we want to be able to tell the computer then to select all the first names, or basically whatever comes before the space. So as before, create a calculated field, and this is clearly something to do with string. So I'll this time select string from the right. Here there are many string functions listed, and you can of course select each one of them and see what they contain and what they describe. They'll tell you a little bit on the right as you click on them. So if you've seen these things for the first time, you can probably click on them and understand from the documentation what the function is capable of doing. Now, if you click on split, a function we have seen before, it has three arguments: the string itself, a delimiter, and a token number. So let's use this. First, let me call this variable first name, and then I'm going to apply this function. So split, it says split. And you'll notice a beautiful thing about these functions. When you type up the function, it prompts you for what are the arguments for the function. So it's string, customer name counts as a string, and it says delimiter. I don't know what a delimiter is. Well, let's just say I didn't know what a delimiter is. I would click on the split function again to learn more about it. Okay, so it shows us the example here that if your string is A dash B dash C dash D, then dash is a delimiter, and 2 is the token number. So 2 is the number of the element if you were to chop it up into, based on the delimiter. In our case, the delimiter is a space, and the token number is 1. And there you have it. I click OK, and now we have our first name variable created. To view this, and just do kind of like a cursory test to see if it all looks good, you can browse these names to verify that they did in fact work out as hoped, as expected. Now, let's say we also want to grab up the last name of the individual, okay, in a separate column. We just want them to be separate. We don't integrate it together here. We can do that in a similar manner. So you could either create a new variable from customer name as before, or we could just repurpose first name. So I'll just create a duplicate of first name. And then let's just edit first name, copy to call it last name. And then I'll go on and split this variable. This time the question is, how do you split it, right? So the intuitive, I guess one intuition would tell us is that if you did a token number 1 for first name, for last name you do token number 2. And so if I do this and go on here, I can go on and put this right by. See it all makes sense. And it does make sense, right? It does make sense for most people. I mean, it's making sense for everybody. I can browse here that my method of splitting the data has worked out pretty good for everybody except Sue Ann Reed, right? For her, it's going to pick up her middle name. So this isn't good enough then. We need to do better here than what we have, right? So let's go back to our variable and edit it. We're going to go to last name, edit that variable. And this time, let's go with something different. To get the last name, we can think of a couple of different ways of going about solving this problem. We could tell the computer, you look at the second, look for the third token number. The third token number is blank, then do the second token number. Right? So like an if then else if type statement. So if token number 3 position is equal to blank, then look at token number 2, else use token number 3. Okay. Right. So that's one possibility. Okay. But a much more elegant solution is to count backwards. The last name is the last word in a name, right? So if you just set a -1 out here, it might do the job. Let's see, okay? Now the beauty about this window here is that I can literally have this thing the way it is and kind of hit apply and see the effects in the background. I'm trying to find Sue Ann Reed and make sure she's in the background. So hopefully you can see now that I've got this window floating above our table, and I've got Sue Ann Reed in the background. I'm gonna hit apply now. On doing so, you'll notice that Ann, I'm hoping, gets replaced by Reed. There you go, it worked. And nothing else got, messed up. So it seems like this is a better solution than our, is correct. The last solution wasn't actually correct or complete. Great. So in this example, we derived a first name and last name from the original name. Let's take a look at another example. In this one, Simple one, right? So here we're extracting the last 6 digits from a very standard order ID. Now, if it's if the order ID format is consistent, that is, it's always 6 digits at the end, I can simply say, give me the last 6 digits, right? Or I could chop this up into 3 parts based on delimiter and say, give me the third token number, right? So either one should work pretty good in solving this problem. Let's try and do this thing here. So let's say order ID, and let's call this order ID digits. And so let's say our goal here is to split, right? I'm not sure that, I don't feel so sure about using the last 6 digits, but I'll show you how that could work if you wanted to, right? So I'll say order ID, use the dashes as a delimiter, and we'll put this right next to so kind of verify that it works, right? Okay. So that seems to work pretty good. You can also try, I'm guessing this also works another way. Let's say you can say edit here. Oops, not edit that. Let's just not edit this thing. Let's make another one of these order ID variables. So let's say here, create another calculated field. I'll call order ID digits 2 or something. Last 6 digits, right? Last 6 digits. And so same idea as before, but this time we can use a different function. So for instance, here, the string, we had a function called write. What write does is it grabs up the last couple of letters or the last couple of whatever it might be in the phrase. You'll notice here as you type up stuff, Tableau will prompt you for the function. I find it handy just hit tab at that point rather than typing up the whole thing because more than likely if I just hit tab, it'll be spelled correctly as the way it should be. So I'm going to now say comma and say num characters, give me last 6 digits, right? And if I do this, I should get another, hopefully this is also going to give us the same result. Let's just verify. So if you eyeball some of these numbers out here, you'll see that you can get the same result multiple ways. One more way is to use the right 6 digits. Okay. Okay. Moving along, a common, problem is to simplify your data, right? So sometimes you got too much data, you want to make it simple. You just want to signal, it appears there. So, for example, in financial markets, folks will frequently simply simplify the market story by saying markets are up or markets are down, right? It's green as an up or it's red as down, right? That's simply. So, in a similar fashion, we're going to seek to dichotomize or binarize, convert to binary a numeric variable. We can do this by converting our data to a Boolean by giving it a inequality. So let's see how we can do this. So here's the sales variable. I'll say create calculated field. And now we can say here, it's a sales, we'll call this like, uh, you know, uh, sales above, oops, customers, oh, I can't think of a good name here. Um, customers 10K plus, right? How about that? $10,000 plus customers, okay, or something like that. And now if I down here, if I say sum sales, where sum is aggregating for a customer, like over the span of time, and I simply say 10,000, right? And if I say, okay, at this stage, you have here true false, customers 10K plus. Right? Now, I can take this variable I've created, which is true false, and use this quite effectively. By the way, here's a neat little thing. You can always inspect a variable by doing describe on it. So this might have gone off zoom screen possibly, but when I hit the caret here, there's an option called describe that shows up. If you click on that, it's going to pull up a window which is going to show you, in this case, only shows us the formula. It's not really super helpful, but sometimes it might give you some more useful information. Now, let me show you how you can use this effectively. If I drag this customers 10K plus variable onto color, what it's going to do is going to give us a color-coded result where numbers above 10,000 are orange and everything else is blue. There you have it. Okay, so you can then use this binary variable for highlighting some of your data if you wish to, or even as a filter. Now, there are times when you may want to do more than just convert to 2 levels. You might want to convert 3, 4 levels, right? And if that's the goal, you may want to think about doing something like going beyond just like high, low, greater than something type thing to some sort of an if then else type situation. So here we are. So Tableau accommodates if then else type expressions um, where some of these keywords are mandatory or required. So if then are mandatory, so is the end, right? The other stuff is all optional depending on your use case. Okay, so let's take a look at how we could do this to create customer tiers. On the slide is an example that shows you how we can set this up. So here I'm saying if some sales is less than $1,000, then we'll use a label bronze customer. Else if some sales is less than 10,000, silver, and so on. If you kind of read into the logic here, it's telling you that if this condition is met, then we're done. We're not going to read the next few lines. We'll just end this control structure. On the other hand, the first condition that is less than 1,000 is not met, then we go and inspect to see if the person less than 10,000, and then so on and so forth. We also have a safety here. What if there's some missing values? So we'll just put them all in a null bucket, right? So that's what the else is doing here. Now, I'll just grab this entire phrase or if then else statement, head over to Tableau. Okay. Right, so let's head over to Tableau now, and in Tableau, I'm going to create a new field to include this if then else logic. So far, we looked at a number of cases where I created variables by going into the variable, caret, and then did create calculated field. Let's change things up. This time around, I'll go to the caret on top, and from here, I'm going to select create calculated field. Now, I'll call this variable customer tiers. Our goal here is to basically create 3 tiers of customers. That's what this code is going to do. So it's going to go through and create 3 tiers of customers. And if I hit apply, let's see what happens. We get a variable called customer tiers on the left. Okay. Um, like we did for the binary variable, we can use customer tiers to color code our data as well. So here we go. Drop it on here. You can see now that the high value customers are orange, then you go red, and then the ones below 1,000 are like blue or bronze customers. So I'm gonna scroll a little bit here to get there. Let me just see if I can get there to blue. And there you go, blue. Sure. Okay. So this is a handy little way to be able to highlight your data by putting them in these different customer tiers. Okay. Moving along, let me highlight or show you how you can do something called binning. Binning is often connected to frequency distributions, and which are linked to histograms and then your distribution curves for your data. So it all begins though with converting your data into binning your data rather. So we have here a variable in front of you called sales. Let's take sales and try binning it. The act of binning is kind of like saying, let me create these boxes and put data into these different boxes. So you got this data that's going from here to here, and your data, the numbers are 0, 1,000, let's say 1K, 2K, and so on. And you're creating these boxes, right? So whatever fits into the 1K to 2K box goes in that box, and so on. Let's say you have like a lot of data in this under 1K box. So you got like 100 data points out here. This could be like 50 points. This could be 10 data points. And if you want to make a bar chart out of this, you could do this something like this. And so you have now basically a histogram type thing showing up. Very, sorry, this is like really tall. Maybe a very tall, like very skewed type distribution. As you can see, it's kind of going down like boom, like that, right? So it's very skewed distribution. Okay, that's our ultimate goal out here, to bin our data and then uh, oops, bin our data and construct some sort of a distribution out of it. So to do this, let me take sales and let's do the binning part. So sales, we're going to create bins where basically we're going to say tell Tableau that, okay, let's define like $100 bins. Okay, so every $100 is a bin. So the example I showed you was 1,000, say $100 here. And we're going to get a lot of bins, of course. So hit OK. So that's all it takes to make a bin variable, a variable now called sales bin. Let's see how we can use this effectively. Okay, so I'll try and construct here a histogram to show you how you can use a bin variable to examine the distribution of your data. I'll toss sales out of here altogether. So now all we have is the customer names. And customer names also will convert into a different kind of variable. So right now, customer name, remember, is a dimension and it's discrete. Now, a dimension can be converted into continuous. You'll recall blue is discrete, green is continuous, but what if we were going to count the number of customers? Well, when you're counting customers, it's now it's continuous, right? Because counting is like a number line and stuff. So we get now count here. Now, what if I now decided to break this up by sales bin? So I say put sales bin on here. Now we've suddenly got a distribution. So you can see out here, we have 6,375 customers in the 0 to 100 bin. And, about 1,200 of our customers spend between $100 and $200. And fewer number, 683 spend between $200 and $300, and so on and so forth. The numbers are dropping very, very rapidly. It's a fairly skewed distribution, right? So like a long tail out here. I guess that's like the long tail of they talk about in e-commerce and so on, where most customers spend like a very small amount on you. There's some customers spending big bucks though that are all the way on the right. Okay, so we've then also examined how you could bin a variable out here. Let's move along now and examine. In the interest of time, I'm going to go on to examine. So there's an example here of dimension to categorical. And going back to the slides here, you could also, yeah, you can use what is called a case statement here to convert dimension to a categorical variable. So, for example, in this case, you could take this data here as follows, and you can construct what is called a categorical variable here, a new categorical variable that identifies the offices of the different regions. So it's basically for the region is central, then we'll call it Chicago office and so on. So this is what is called a case statement then, right? So another way of doing if then else, and this essentially is a case statement. So to illustrate this idea, let's head back to Tableau and let's do, I'll create a new variable out here, create calculated field, and I'll call this regional office, right? So say regional office. And again, paste snip that code in here. And it says calculation is valid, so it's good, right? And so the logic here is very simple, saying Central has the office, Chicago office, East has, depending on the region, you've got identified a different kind of office. So, okay. And I'll drag regional office over to the right now so you can see in a sense where all this fits. So, so you can see now clearly Alabama is one office, Arizona is one office, and so on by creating this new variable called regional office. All right. Moving on. We're now going to look at how you can do kind of you can do calculations with dates as well. Actually, a very powerful idea, right? So we use it in when we speak all the time, right? So we talk about today and next week, and like that's next week. So we're talking about the difference in time, or we're talking about how much time remains for something to happen. So we're talking about time difference oftentimes. In our heads, we're doing some math between dates or times. Um, in Tableau, there's a function called datediff that enables us to construct these date-based kind of computations. So let's look at how that would work out. I'm going to create a new calculated field, and we'll call this order processing time. Order processing time is the time it takes for the company to process your order. And that's from the time they get the order to the time they ship the item out. That's your order processing time. We have two variables here. One is called order date. I'll drag and drop. So you can see you can also drag and drop stuff in here. Another one we got is ship date. We want to compare these two things, right? So I've just put them in side by side right now, but we want to find a way to compare these two things. And so there's got to be a function to do that. There's got to be a date function. So look under date. Here's that datediff function I alluded to earlier. Datediff enables us to compute the difference between two dates, but the function isn't, that obvious, right? So the first argument here is date part, which is the unit we want our date to be in. So the function goes like this: date diff, and I'm going to say here date diff specify date part, which in the example it said you could do something like this, right? Day. It's got to be singular though. Could be week, could be month, could be hour. We'll try hour shortly, but here's what it looks like with the setting as day. If I hit OK on this, you're going to get order processing time in days. Now, I'm going to drag order processing time that's been created over to text. So you can see now quite clearly the sum of order processing time, which isn't very meaningful. So I'll make that average first. There we go. So now we have the order processing time for the different regions in days. As I noted, you could, of course, express this as, let's try this, edit. And we'll go here and say, let's say this is, to be silly, okay, minute, okay. Why would you want to be minute? Well, we'll just do it for the heck of it, right? Click apply. And now in the background, you see we've applied these changes, and you can see now it's showing you the order processing time in minutes for these different regions. Okay, so moving along, let's do one more thing and then wrap up, right? So this is going to look at how you can combine levels of a dimension. Um, so let me give you some context in this or color in this before we go on. So a very common problem that I face when I work with data is that sometimes I have these sparse categories. Like I collect age data and I find out that everybody is in like 3 age groups and nobody in like this fourth and fifth age group. Sometimes there's nobody in the older and higher end of the spectrum, but I gather data on that anyways, in these sparse categories. So what I may often do is to try to combine these sparse categories to make a larger category. For instance, if I gather data on age and I have very few people who are 40 to 49, 50 to 59, or 60 plus, I might just pool them into a 40 plus category. In general, when you're visualizing data, it makes sense your story is much more compelling if you can combine these sparse categories, unless you're really looking at a niche category for some reason. Also, in machine learning problems, it's very common to combine sparse categories into larger, more balanced categories. It seems like models work better if your different categories are fairly even in terms of the number of elements in them. So often we want to balance these categories out, and so that's one common kind of reason why you want to combine levels of a dimension. I'll give you one more example. So imagine you've got data on marital status. You ask in a survey a question like, are you married? Are you single? Are you divorced? Widowed? On a break? Uh, separated? And so on. And you find out that pretty much everybody is either single or married. So the other four categories can be pooled into an other category, right? So there's that. Now, to illustrate this, there's many ways I can illustrate this, but I'm going to go with a curious, interesting illustration where we're going to look at this data using or do this in a very visual kind of Tableau style way. In our data set, Sample Superstore, is some data on the cities where customers of Sample Superstore reside. I'm focusing here on the cities in New Jersey. Okay. Unless you know New Jersey, you don't know where these cities are located. Now, in New Jersey, folks commonly refer to the different parts as being North, Central, and South Jersey. Let's say we want to categorize our cities into the regions of New Jersey, North, Central, South. You can look up a map. Yep, you can do that. Or you can do this very visually, Tableau style. And that's what I'm going to illustrate out here. Along the way, we'll learn a few things as well. So I'm going to kind of do what I'm going to go do here is I'm going to start create a new worksheet. Okay. In this new worksheet, we're going to create this regions of New Jersey variable. Okay. So let me locate city. If you double click city, notice again, city is a globe, meaning it's a geographical variable. If I double click this, I get a map showing up, the map of the United States, along with all the cities marked in. Now, I want to focus on New Jersey, so I'm going to filter for the state of New Jersey by dragging state over to filters, and then selecting the state of New Jersey. This will only show us the states in New Jersey and not in any other part of the country. Now, I'll visually select these by drawing a rectangle around these cities that are clearly in the northern part of Jersey, right? And I'll let go of my, after I select, let go the mouse. And now I get prompted for some options, including a paperclip icon, which is the symbol for grouping things. Click on that. And that asks me city, state, province, country, region as the first option. I'll click on that one. It has now created a legend for me on the right and also highlighted these cities. Now, I know they're in North Jersey, so I'll simply relabel this as, I'll edit the alias to North, right? Like Northern Jersey or something, or okay. Similarly, I'm going to go and highlight this city in the center, and when I see the paperclip, I'll click on that, and again, rename this to be Central. Lastly, the three dots in the south, select those, and look for the paperclip to show up. I don't see a paperclip showing up. Sometimes a little delayed, so you got to be a little patient with that paperclip icon or option showing up. So here, and I see it now. I'll click on that one. And now we have a third one created. I'm going to rename or edit the alias here to say South. That's it. So this has enabled us to create basically this categorization. It may not be obvious to you, but this was merely a means to an end. The end being creating this variable that has the regions of New Jersey embedded in it. So if I were to, let's just say, delete this sheet, it'd be okay because we got what we wanted here, which is this variable. I'll edit the group and I'll call this regions of New Jersey. You can see here listed are South, North, and Central. And other is all the other cities in the data set that are not in Jersey. Click apply. Okay. Oops. I'm in the wrong sheet. Okay, that's okay. Um, I went to the aggregation sheet. I wanted to be in this sheet, but it doesn't matter what you do on the left because what you do with the variables applies to all the sheets. So there's no issue there. Going back to combined levels of dimension, I will now drag regions of Jersey over right next to city, and you'll see now they're getting categorized nicely. You can see now on the left are all the regions of Jersey being listed. Let's make it some space to breathe here. And central, north, and south, and it categorizes now nicely your regions and the cities. You can see which region they map to. And you could have done this without even knowing your geography in New Jersey. In fact, we just literally did that, just that. Okay. All right. To sum up, here is what I have gone over. I've gone over various methods for transforming your data. This includes taking a numeric variable and constructing other numeric variables from it. I also illustrated to you for you how you could perform functions with string variables, like, for example, extracting the first name or last name from somebody's full name, extracting digits from an order ID. We examined how you could convert a numeric variable into a binary variable by giving it an inequality, or by converting it into groups using if then else if statements. We also examined the option to bin a variable. We then examined how you can convert a dimension to a categorical variable. We computed date diffs to compare dates based on some unit like minutes, hours, weeks, so on. And lastly, we examined how you can combine different levels of dimension, and we did so visually to really showcase the capabilities of Tableau to do this analysis, to make the analysis truly visual. Thank you.